Hi guys, subscribe to my channel, press like button, and leave a comment, and share this video among the world. Let's go, yo! So today we are going to watch Mozilla Firefox, and this is the browser. And I mean, why we cannot just compile it, right? So actually we can, right? Because as I already searched, it is pretty easily accessible, right? So we just build Firefox from source. Yeah, it's in Mercurial, it's not in Git. Wow, what? What? Okay, okay, guys, because previously I found that the same response but from Mercurial. Okay, nice. So gecko dev. What does it mean, by the way? Gecko dev. An explanation source it links the project. Wow, thanks. How to build and create the patch C. Nice, nice. Okay, so let's just clone. And by the way, yeah, just clone. I don't really care. I saw that we should clone like only last comment, but I mean, it could not work in sometimes, so it's easily just to clone it as is. Um, okay, wow, it's pretty, no, it will be long. Okay, so I will stop the video right now. I will go to do my stuff and then I will come back and maybe we will do something else while it is downloading. Oh, guys, it's really quite large. I don't know. Should I continue because my PC is limited in resources, so to be more specific, I have here is my root, right? So 53%. So available in human readable form is 52 gigs. It's already installed 5, and it is like one. Oh wait, maybe it's not all. So maybe it's all the size is all, and now it's doing some stuff. Yeah, okay, that's okay. Anyway, it wow, yeah, it's gonna be fast, I think. Yeah, it's gonna be fast. Okay, no problem, guys, no problem. Um, okay, guys, so it passed not a long time to be honest. Like, it's okay, it's usable time. So wow, I have a lot of MP4. CD Gecko, right? Okay, so let's check out what we have. My God, I see cargo, and this can mean that cargo and the cargo is Rust, I think. Okay, I have a configure, and it's pretty cool because configure with a script is usually rand, so we can start from it, I believe. Okay, we have make file, so it will be, but it is in, so it will be used, but not by us. Yeah, so let's just run this configure. Configure. Nice. Okay, that is common one, so we need to make dir build. Wow! Oh my goodness! Wow! Okay, I don't know what is this stuff. I mean, if it's pre-built, it's not, but cannot know it, right? So I will do another one. Okay, double configure. Okay, nice, nice. We know this stuff, you know. We are familiar with this stuff. Wow, it's Python. So yeah, as I said, building Firefox should be like very complex comparing to Linux, because I mean it is using a lot of stuff. So If Linux is, we need basically, I think, only compiler and that's all, but for Firefox we will need a lot of stuff. It's strange, right? Because I mean, it's just a browser, it's just rendering HTML, right? Why it's so hard? But on a practice, it's really hard because you know what? I've tried like searching for a minimal browser and I find like perfect one that I like. I mean, at least it's philosophy. It's called Surf browser. It's from Suckless software, suckless.org, right? It's quite good. I like it. I mean, but the philosophy and minimalism, but it is not working in a modern world with the modern web pages. Okay, I think I have an error, right? Rust compiler not found. To compile Rust language sources, you must have Rust C in your path. You can install it by running match bootstrap or directly running the installer from Rust app. Okay, so let's run match bootstrap as it suggests. Your choice. Okay, I don't like this because it means like we will not actually compile. Okay, so I will cancel this. Okay, so basically we need a Rust. Okay, so I don't know, sudo apt install Rust. Okay, wait. Nice, nice, nice. I'm a genius guy. Look at me, I'm a genius. You know, you're looking at the genius right now. Just remember this face. Okay. Hmm. I need the tube. 1 second, guys. Okay, guys. So what do we have? We installed Rust C. So let's run configure. Hmm. Seems cool. Seems cool. Cargo package manager not found. Okay. 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 We can deal with it, right? I mean, we can fix it easily, right? Yeah. Yeah, we can. We are the owner. We are the creators, right? Of our own destiny, okay? So let's go. Okay, seems better. Seems cool. Okay, it is downloading some stuff and you can think I can think that it is not very cool, but I hope it is just downloading tools for a compilation, but the actual code is will be compiled, okay? Um, Hopefully this will just configure because it's configure script, not make execution. So we are not compiling anything and we did not need it to use all cores. Okay, okay, some static stats, but actual command was successful. So what do we get? I just want to run it. Oh my god. Okay. Got a browser, nice. Um, Whoa, nice. Oh man, man. Man, I know you. Hey, brother. Yeah, man. Man. Minus J4. Let's go. Wow, guys, I like that. Do you like that? I mean, it is a good. Um, I will just take myself out, for you to see this beautifulness. Okay, you can imagine, of course, my face, but I mean, I am relaxing. I'm enjoying. What could be enjoyable? Some people say that you can watch on three things, right? Infinitely: water, fire, and this. This is the main thing that people, peaceful people, like normal people, watches. So if you know, if you will sit with the screen on some public park and some girl, any girl to be honest, like Angelina Jolie, like any I don't know, Kim Kardashian, like any girl, any, she will see it, and you know what, she will just I don't know, I fall in love with you. I mean, because you're the best man in the world. Yeah, that's unfortunately, yeah. Women these days are very very attracted by this stuff. So unfortunately, you will have to deal with this. You know, this is how world is. So yeah, if you will continue doing such stuff, be ready for gigantic woman attention. Okay, guys. So I don't know. Do I need to actually have you watching this whole process? I mean, it's very relaxing, so I don't know. But if you will watch it full, maybe you will not do it yourself, right? So maybe if I will stop the video and wait until it finishes without recording, maybe it will motivate you to do it yourself, to look at it, right? But I understand that not everybody will do it, so maybe it is a good point to watch it. But yeah, to be honest, no. Let's just continue with C++. Yeah, guys, sorry, but that's how life is. I mean, not everything is around building, you know. Sometimes you need to do real work. Okay, so you can watch. Uh, you can watch this masterpiece while I'm preparing for C++ session. Ooh. Oops, I spoiled the book. No worries. Oops, I spoiled it again. Oh my god, I have so many spoilers. Um, okay. So last thing we talked about C++ is namespace, right? Okay, so the next thing we will talk is wow, why I have two Firefoxes? Firefox, are you duplicating yourself or what? Um, yeah, so C++ register. It's very interesting, right? Yeah, and also let's just look at gotbolt.org. Nice, nice. Look at me. Look at me, guys. Oh, by the way, I will watch myself. Ah, well, I'm showing. Oh, nice. Oh, wow, I didn't spoil anything. Nice. I'm the best. I'm really the best, guys. Okay, so we have a simple program. So let's call it int main. It will be. Oh my god. It will be empty, you know? Nice, nice. We have some assembler here. Anyway, so I can have some variable. Let's say equal one. Okay, now what will happen if I say that it is a register variable? Just watch. Doesn't really show anything. It's very strange. Hmm. It's really strange, guys. Maybe I cannot even manipulate it. okay, what is okay? It's still building. Wow, it's pretty fast. I mean, you look like 1/3 or 1/4 is already there. Yeah, last time I did not succeeded even starting the build, but maybe that was not Firefox but Chrome. That can be the case. By the way, does really Firefox is written on Rust? Oh my god, if that is the case, why doesn't it say the language? I want to see the language. Okay, let's just see source directory. Okay, they don't have source directory. It's interesting. CG gecko. Find minus name CPP. Okay, we have obviously CPP, so C++. Okay, so it's written on C++, right? But Rust is Rust file extension. RS, okay. No, I mean .rs. Okay, so we have a Rust also. Yeah, it's cool. Okay, it's cool, Firefox. Cool, great job, Firefox, of using multiple languages. Um, okay, so coming back to the register. It seems you're asking about C++ register and blah blah blah. Registers are small. Wow, fast storage location within the CPU. That whole data is being processed in C++. We don't directly manipulate register like we might in assembly language. Yes, yes, I know that. But we can optimize code to take advantage of CPU register for performance improvements. Here are a few key points about register. Okay, give me some sample actually, because I know words are cool, but I need a sample. I need it. Mm, mm, will you give me some register? Where is register keyword is likely to be heavily used and should be stored in CPU register for faster. But I don't understand the statement. I mean, uh, we anyway load our variables to registers. So what does it mean be stored in CPU register for? I don't understand the statement. Maybe it does mean that we like keep it in our register, but again, um, I don't think we can keep in our register anything because our how to say our how to say this, guys? I mean, CPU registers are constantly switching context, so we we anyway will we cannot store anything permanently in register. So this statement is quite understanding for me. Okay, let's finish with registers and let's talk about. Okay, wow, it's wow, Firefox, you're wow. Um, yeah, let's talk about one thing that I have two browsers. Okay, no, let's talk about one thing specifically. Uh, I was wondering, like how to. I mean, PC speed, right? So this compile speed and usual usage speed, right? First of all, usual usage speed, like use browser, I don't know, some terminal, some text editor, blah blah blah. Maybe even some, yeah, that's all. Is quite easily, right? But like stuff like compiling, okay, so it's quite hard. So for example, this one I'm compiling using 4 threads, right? By the way, let's look. Oh my god, are you? Oops. Wow, you're so slow, man. Yeah, that's what I'm talking about. So my CPU is currently having hard times, you know? Yep, you see that? So my CPU is fully loaded, and that's, I think, because I splitted compilation in 4 threads. So of course you can imagine, and I'm using only 2 and 1/5 memory. That's really interesting. So obviously that the more threads I have is better, right? But we have a problem, and I will demonstrate this problem on a real. Um, okay, I will guess. Wow. Okay. So I will demonstrate it using like real example. Okay. So no jokes here. So I will go to computers. Yeah, I will teach you how to use. Wow, it's so laggy because of a compilation. Wow. Um. Okay, here is something processor. So first thing is that there are motherboards that have 2 processors. Okay, but let's just look about. So for example, this one. Okay, I didn't watch on the price, right? But it's obvious that uh, that the price is K feature. Okay, so okay, here you can see six. Okay, six, 6 cores. Okay, so the more cores, the more you will have here. So and the more you can have for compilation. So the more cores is better. But we also have this one, this number. I don't know. Can you see it on the video? I mean, I hope you can, because like my resolution screen is like if you will full screen at least video, you will able to see it. So I believe you can. You know how to full screen video. I will not zoom it. So yeah, it's Gertz number. Okay. So and the bigger this number is, I mean this number. So if we look back again in the assembler, so which row? So first of all programs on a computer is converted eventually is executing actually this methodology, right? So this process, and every command, every line in this assembly code is one. I don't know how to say it in English, but it's okay. It's just one, okay? And this number is showing how many this assembly rows is performed by this processor in 1 second. Did you get me? So the more this number is, the more rows of assembly code will be executed in 1 second. So basically, the more processor has this gears stat, it will actually do the same work, but it will actually do it faster. So in our example, if we're compiling Firefox, by the way, it is almost done. It will if I would have it compiled on, I mean, the speed is heavily uh, impacted by the processor Hertz stat. Okay, so this is the first point. Okay, but the second point is that my compilation or any other task can be broken into threads. So for example, this processor has 4 or 6 cores. Okay, so this is also to have in mind. Okay, so but how I think, okay, let's just multiply this number by this number, and we will get the actual number that will define processor speed. Okay, how do you like this idea? I think it's best idea in the world. Okay, so let's just, I don't know, compare some. So I used this one. Okay, so I will use this one, and we will just try to compare them, and we'll see is our actual comparison. Okay, so here it has 6 also, but it has 3900. Okay, so obviously 3900 multiplied by 6 is more than 2500 multiplied by 6. Okay, so of course this processor will compile or perform any task faster than this one. So let's see, is the price also uh, right? So is more performance processor have the biggest price? So this one, which is which is worser, has 5949, and this one have 5219. And here is the question: why does it? And the answer is, I don't know. Okay, maybe it is because it is not the price is, so obvious answer is that the price is calculated not using only these characteristics. Okay, but again, for me, yes, so I mean, yeah, so of course, like it has some sockets, right? Socket size, and you cannot like upload it to any graphic card, okay, or motherboard, okay. So yeah, that could be the also influencing price, but I mean, for us, it's obvious that the performance is this one multiplied by this one, but also it has some cache, and I don't know what it actually means. So yeah, in order to fully understand, we would also need, okay, so here it's bigger, so it's 18, and here is 16. So I guess, yeah, this is also influencing the number of price. Okay. Yeah, so I don't know. My first idea was to okay, it's not yet. My first idea was to hack the system. Okay, so my first idea was, okay, I will just analyze some characteristics, or I will just um, understand and create some formula that will define the actual goodness of a processor, and then I will choose like low cost processor, but with my formula it will that will show that it is actually good and performance, and I will buy that on the low cost, and I will be like very cool, you know. But in reality, I think I mean we did not came to conclusion, but in reality, I think unfortunately you cannot buy on the lowest price. You cannot buy better processor, and yeah, it's like, you know, it's like configuring Linux. I mean, just use pre-built Linux, and that's all. And the same with processor. I mean, just buy the processor that you can buy. So if you have like x dollars, then try to buy the processor which will fit in this number. So I mean, yeah, if you have uh, Z dollars, buy the processor on Z dollars. So the there is no, I think, like easy way and to buy on less money and with great or the same performance. No, there is no such way, and yeah, unfortunately, yes. And we can easily explain it because I mean, uh, of course, I don't know what this means, but I mean, it is obvious that this thing is actually I mean, what is the main purpose of the processor? It's performance, right? So of course, every characteristics is meaning something and impacting it somehow, and of course, it is impacting the price. So I don't think there is cheats and easy ways um, to choose a processor with some cool characteristics, but uh, on a low price. But I think we can do something with it. I mean, we can analyze this one, number of cores, and why do we can use it? And I will explain now. Because not everybody actually needs this cores. Okay, so that's why I wanted to show you how many threads are running now. um, Task manager, stop. Yeah, okay, let's do this. Okay, so you see, like, right? So I mean, I think it's like a number of processes, right? So actually, the more cores we have, the better I think the performance will be, because it is actually impacting, I think. So even if we take in account all of the characteristics of these processors, I think the most important one is the core sizes. Okay, and if we want to maximize this one, so what is the problem, you can say, right? So we can just filter, and unfortunately we cannot like order in number of course, but we can like here we can choose the number of cores. And of course, for example, we have like 96 core processor, right? But it is actually unavailable, and it is actually like costing, I think, a lot. By the way, you can see that Gertz is very slow here. Okay, let's check 84 cores. Okay, it is also unavailable. 64. Okay, they're also all unavailable, but you can see the price, right? So the price is really big, and it is logical, right? So even if you have like, yeah, it's logical. So the more cores, the more price. So here is another point that you cannot actually buy low cost processor with a lot of cores. Okay, so this is the answer. Okay, so the next thing I wanted to check is that there are actually a, a motherboards. Okay, so okay, here is a question for you guys. So if we if we want a lot of cores, but a processor with a lot of cores is cost a lot, um, what can we do? Okay, and just pause the video and try to answer. Okay, 3, 2, 1. Okay, time is over. So what will happen if we will, for example, like this processor is costing like a lot, right? So the processor with like half of the 64. Okay, let's just look at those numbers, right? It's all 64 processors, right? And now I will uncheck this 64 processors, 84 and 94, and remember 64, right? And now I will check 32. What do you think will happen? Does it load it? Ah, okay, it's loaded. Okay, and I see the same prices, and it is embarrassing me, to be honest. Okay. Um. Anyway, I have an idea. So there is a motherboard that have two sockets. So you will have two processor. So it will be twice cooler. Okay. There is some limitations, like they need to be the same, but actually we don't care, right? We will buy like, okay, the same, no problem. So let's just yeah. So my thought is that we, for more cores and cheaper price, we can combine motherboard with two sockets. and it could be the best choice. The problem is that I don't think those motherboards are quite new. So first of all, I don't like that here is no special thing for specifying two sockets, right? So I would go like from the cheapest. Okay, I don't want actually to spend a lot of time, but let's see, maybe we will be lucky. Um, mm, okay, okay, nice. So already I see this one, for example, yeah. Okay, so yeah, but the main problem is even this motherboard is two processors, right? Here is another problem. So we cannot actually insert all stuff in here, okay? So because this motherboard have some specific socket, right? So um, so yeah, processor model is X5355 for this motherboard, and yeah, so you can see that it has um, 4 cores, okay, 4 cores. So even if we buy this in quantity of 2, we will get like 8 cores, right? But what is the point of this if we just can buy like one 8-core processor and it actually will cost even less? Okay, is it possible? Is it possible, guys? Is it really possible? Okay, so no, they're pretty. Okay, I see. Okay, guys, I see, and I hope you see also. So they are pretty expensive. Okay, so yeah, it's better to buy this motherboard and combine it uh, with a cheap processor, right? This one, X5355. Uh, Other problem may occur that this processor is not available. Okay, so let's check its socket. Yeah, just let's check the socket. So we'll just I don't see a socket. Okay, let's search socket. Okay, uh, LGA 771. Okay, 771. I guess. Um, so here we can search 771. So maybe I believe this one 771. Okay, we have only two of them. Uh, let's see. Okay, nice. Okay, this is very cheap to be honest. And here is like 2 cores. Okay, and here is 4 cores. Okay, guys, so I think that is good. I mean, for me it is good. Because right now I have 8 cores, right, or 4 cores. Let's check. Now fetch. Oh, of course, man, of course. Yeah, of course you can check it in other methods, but this one is pretty cool. And I will have to remove myself for this one. Sorry, guys. Just imagine my face. Oh my god, it's so cool when you don't see me. I can do anything. Um, you know what I'm porting? Now fetch our kernel. Um, CPU, right? So yeah, 4 cores. Okay, so uh, if I will search this, by the way, this number is quite good. Um, yes. And if I will search this one, just to make sure it is, I will get myself back. Um, how many cores? Okay, 4 cores. Okay, so that's why. Yeah, so I get 4 cores. So this is the problem, guys. So why I have 4 cores if I can just buy uh, those two processors that will have both 4 cores, and I will insert it in this motherboard. I will insert two of them, and I will actually have a boost. Okay, I will have 8 cores. And by the way, this costs like 4,000. Okay, and in sum, this will cost like around 2,000. Okay, so I get like more cores and cheaper price. Okay, so that is the reason I think I should do it, because I mean it doesn't really matter. I mean, for a regular use, of course, it doesn't matter because you just do stuff, not compile anything. Also, you can say like, yeah, I will get more cores, but actual speed will not be the good, very good, because here is 2.5, right? And here is 3.5. So this one is in a, well, I don't know, but it's bigger on 1 gigahertz, and 1 gigahertz is quite large. So um, if we will divide it, uh, yeah. So actually, let's multiply how I said. So 3.5 multiply on 4 is 12, 14. Okay, 14 gigahertz. 14. Okay, remember 14. And this one, this one, we will have like two of them, so 8 cores multiplied by 2.5. It's bigger, right? Yeah, man, it's bigger. Oh my god, it will be like 16, it will be 20 gigahertz. Okay, guys, I'm definitely buying this. I'm definitely buying this, guys. I'm definitely buying this. Oh my god. Oh my god. Oh my god, guys. I mean, possibly I don't. I mean, I don't do need it. Okay, because this command, when it will be ended, we will build our Firefox, and I don't plan to build anything more. So yeah, let's continue to wait for a compilation, and while it is compiling, I will just monitor it at the right, and we will continue with some C++. Okay, so the next word is reinterpretcast, and it is pretty interesting because I don't really understand it. So let's try to understand it. So reinterpretcast is a type of C++ cast. I will get some water, guys. 1 second. Okay, guys. Breakcast is a type of C++ casting operator that lets you convert a pointer type to another pointer or a reference type to another. Okay. Mm. Regardless of the type compatibility. Interesting, guys. But first question is that what is the difference between? Do we have some folder called C++? No, we don't need it actually. Int main int I. Oops. So dynamic cast, reinterpret cast, static cast. So static cast, dynamic cast. Oh my god, it's so hard. Okay, let's imagine I have double and I have integer. So I want double to be equal to integer. Of course, here, here, here will be easy conversion, right? But I don't want it, so I will create class 1, class 2. Of course, I will define them. Struct class 1, class 2, and I will compile this program, and it will fail, right? Yeah, yeah, okay. So I can do in C, I would do this class 1, and it will work, right? No, no, no. Oh my god. Okay, so the question is it about only pointers? I guess yes. I guess yes. I guess yes, guys. Okay, I mean it's okay. So casts are for only for pointers or references. Okay, I got it. I got it. So create a point. Okay, we will start with pointers. Okay, so I want a pointer to be equal to this one. Okay, or I will create actually another one. Uh, Class. Actually, I will just add here this sign. So yeah, let's do it. Let's do it. Will it fail? Of course it will. Cannot convert. Okay, no problem. So in C, people are doing something like this, and that's all, right? It's and this is works. Okay, okay. I will make myself fit. I will be fitted. And this will work, right? Actually, and I think it is the same as stat. I think it's std, right? Std static cast. Wow, cool color. Thanks, Vim. Class 2 e. I don't really think it will work because undefined. Maybe I should include something. No. Expected unqualified ID before static cast. What does this means on Earth? Maybe I don't need std, I don't know. It's strange. No. Mm, invalid static cast from class. Oh, okay. It's better because we get another. Okay, so first we don't use std, and second static cast fails if the classes are different. Okay, it's okay. Of course, if we don't define some conversion in class itself. By the way, how to do it, you know? Just let's remind. Class 1 operator 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 class 2, I guess. Return, I don't know, return class 1. It will not work because I need to define struct class 2. Is incomplete. Yeah, this is the problem. Okay, for this one we can just place it on top. But in real world we will have header files and that would be no problem. Okay, and this one is pretty strange because I mean we defined, right? Okay, that's cool. Class 2, class 1. Okay, so what if I will do something like that? No, but it will actually work because it is okay. Also, we can do it like this, and it will work also because we define no. Con why conversion class 2 operator class 2? Very strange, guys. Very strange. Let's quickly check. Create conversion from one class to another. I did the same, right? I don't know. Let's change to double and say return 2 and say double. Mm, Okay, this one works. So what is the problem with class 2? Class 2. I agree with you. Okay, this one worked. Okay, so we have it, okay? We have it. And what if we will do pointers, okay? Pointers. It is failing. And I have a question why. Um, okay, maybe pointers have some another algorithms and that stuff, right? Because I mean it's different classes, so we cannot have a one pointer convert to another pointer, okay? And this is obvious. But but unfortunately we can use reinterpret cast, right? And here where it comes into play. It seems like that. So reinterpret cast class 2 star. Okay guys, so I hope you understand, right? So but what is the problem here? Okay, so let's say d e equals or lol equals 2, right? So in class it will not compile. Oops, it will not compile cause struct 2 has no member lol, but if I will add it int lol, then what? Yeah guys, so as you can see, this is for what reinterpret cast is created, okay? I think it is obvious right now. Okay, it's great. It's great. What's next? Short. Okay, short. Yeah, I think it's not interesting. Signed size of static. Static assert. Okay, static assert. What is static assert? Static assert. Looks like simple assert, but static I think it's allows you to perform compile time assertions. Compile time assertions. Interesting. Okay, let's try. Let's remove everything. Int main static assert condition will be 0, message will be lol. Static assert failed. Nice. And it is on compile time, you see. So even if I will do -c, it is on compile time. Okay, that is what static assert is. But what if I will do something stupid, like, I don't know, int I equals blah, or equals rand? Yeah? But I will need to do include EOStream, just rand will be able. Whoa, you see non-constant condition for static assert. So it's only for some constants, okay? Okay, pretty cool. Static cast, I think we talk about it. Struct switch. Switch is boring. Okay, template, I think you get them. I mean, it's not very hard. This thread local. Okay, what is thread local? By the way, what is compile condition? Okay, it is still compiling. Okay, let's check. Thread local is a storage class specifier introduced that allows you to create. Okay, very interesting, but okay, it's like a modifier for some variable with thread local. Okay, but what is the point? Do you get any point? Mm-hmm. Mm-hmm. Yeah. Thanks for sample. So what do we do? So this thread local variable, and we have two threads. We both execute those threads, and those threads are incrementing this variable, right? So the question is value in main thread, okay? So I guess it will be 0, okay? I mean, it's thread local, so in every thread it will be local, so it is not global. That's why it is no race condition, blah blah blah. Okay, let's try. Yep. Okay, pretty easy. Thread local keyword throw is easy. True, try, type def. Okay, type def, it's quite hard. Type def. Okay, it's basically just creating new type. Okay, it's aliasing. Okay, not interesting. Type ID sounds cool, but it's like for type recognition, right? Yeah, so we get some recognition. We say some names. So let's try. We have int stdc out type id of e and then name. Like this? Okay, like this. Like this or like this. What? It's maybe int able will be d. Okay, guys, that's all for type ID, I think. Type name. Type name. Okay, I'm not sure. Template. I'm not sure. Let's check type name. Is it blah 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 blah? Oh, okay. No, it's just in templates. Okay, it's not interesting. Union is also not interesting. Unsigned using. Okay, using is quite interesting because we can do like using name space std, right? And this will compile. So without this, for example, um, oh, so this will compile. But what if I will say using std out? It is also wow. Wait. Remove this. Yeah, you see, so I specified only this one, and this one succeeded. And okay, virtual, I think it's okay. Void, okay. Volatile. Volatile is that variable can be changed, and this is in embedded world. So it's when device is changing your variable. VHRT, I think it's Unicode. Wow. Okay, guys, I don't know. We are the best because we did all the keywords in C++11. Um, this is really impressive. Um, okay, I want to try something. Return 1 and 2. Wow, guys, so this is actually working. Wow, wow, guys, this is cool. I don't know what is this one. What is compile? Okay, it's some, I think, bit operations. Okay, no problem, guys. I mean, it's fun. It's fun that C++ have or and, right? 0 or 2. It's really cool. I don't know. I don't want to talk about void pointers. It's stupid, I think. Um, Also, I think we don't need to talk about pointer to pointer stuff. Yeah, it's pretty simple stuff. I don't know what to talk about next. It is still compiling, and this is perfect. Okay, I will stop the video for a second, and we will see what. Okay, it's already 1 hour. Okay, yeah, probably let's just finish this video. I don't know. And I will start another one. So, subscribe, press like button, comment, and share this video among the world. Goodbye, guys.